Hello kids, I'm back again here with Standard 8, Subject Physics, Chapter is Force and Pressure, Part 3. In first and second part, we had already discussed regarding force, pressure and pressure exerted by liquid. Now in this part, we'll discuss about a device named manometer which is used to measure the pressure exerted by liquid. For this, we are having the arrangement of manometer as which consists of a U-tube made up of glass with two arms, arm A and arm B, which is placed or mounted over a wooden plank over which one scale is also fixed to measure the rise or fall in the liquid level on either of the arms. With one arm, we here attached a thistle funnel along with a rubber tube. When the pressure is exerted on the rubber membrane attached to the mouth of the thistle funnel, it will exert a pressure that will lead to the fall in atmospheric pressure on the arm A and rise in the pressure, liquid pressure on the arm B. So when the pressure is being exerted on arm A, the liquid present, there is a rise in the liquid level of arm B, and the difference between the arm A and the arm B due to the liquid present, that will give the pressure exerted by liquid on by using the device manometer. Now we'll discuss about pressure exerted by gases. As we know, all around us there is an envelope of air that will exert a force on us on unit area. So the force exerted by atmosphere per unit area is known as atmospheric pressure, and in SI system its value is equals to about 1,01,325 Pascal. The atmospheric pressure above us is equals to almost 7 compact cars. Then why don't we feel that much huge pressure on us? Because the blood pressure inside our body is exactly match the atmospheric pressure outside the body, that is due to the envelope of air. Now here we will discuss about one application of atmospheric pressure by using an activity. This activity is about the air pressure that is exerted in all direction. For that, what we had done, we had taken a can and inside which liquid is there. Now the liquid is being heated. What will happen? The liquid present will convert into vapor and rises up. Then the cold water is being poured over it. What will happen? The air as a vapor that will comes out, that will create a less pressure inside, and when cold water is being poured over it, then the atmospheric pressure from outside is more. Thus because of this pressure outside, more pressure, inside less pressure, there is a pressure difference created and this can crushes inside. Some more applications are there that we are experiencing in our daily life, that while using a fountain pen or ink pen, how the rubber tube, through the rubber tube, the ink rushes in. When the rubber tube is being pressed, the air inside the rubber tube comes out, and when this ink pen, tip of the ink pen will put into the ink pot, there is less pressure inside the pen, as because of pressing of the rubber tube, the air comes out. So the outside pressure will help to rush the ink through the rubber tube in the fountain pen. The mountaineer suffers nose bleeding at high altitudes. As we go more to the high altitudes, the atmospheric pressure gradually decreases because of the less density of air and less atmospheric layers of air. Thus, on the high mountains or altitudes, mountaineers suffers nose bleeding. Why? Because the inside blood pressure will become more than the outside atmospheric pressure. Thus, blood used to comes out through their nose, mouth and ears. Astronauts wear special suits. In space, there is almost zero atmosphere. So there, to withstand with that atmospheric pressure or outside pressure, to maintain the balance between that air outside pressure and the inside blood pressure, astronauts wear special suits. Now we will study about some instruments that help to measure the atmospheric pressure. So here first we will discuss about simple Mercury barometer. Simple barometer or simple Mercury barometer, that is invented by Evangelio Torricelli in 1643. It is used to measure the atmospheric pressure. Here we have the diagram of that. Here we have a simple, as by its name, simple barometer. A simple trough is there and a long tube is there. Both are filled with mercury. What will happen? That when the tube is being inverted over the trough, first there is a fall in the mercury level and there is a rise in the mercury level. Why? Because as the trough is open, there is an atmospheric pressure that is exerted on the mercury that is present in the trough. Because of that atmospheric pressure in the liquid present, that is mercury, so the level of the mercury rises up and there is a vacuum space left, that is known as Torricellian vacuum. Thus, with the rise in the mercury level, we can measure the atmospheric pressure of different places that will differ from place to place. As on the open liquid or mercury, the atmospheric pressure exerted on it is different at different places. What are the disadvantages of simple barometer? It is not compact, not portable. We cannot take it from one place to another as it is open. The mercury level can change as trough is open, so there is no permanent scale can be fixed to use the mercury level from place to place. It can vary. We cannot fix the scale. There is no permanent scale used in a simple barometer. There is a chances of impurities getting mixed as it is open, so there is a chances of impurities getting mixed with it that can vary the atmospheric pressure. In place of mercury in a barometer, can we use some other liquid? So here we will compare some of the advantages why we are using mercury, not water, as a barometric liquid. Mercury has the highest density, that is about 13.6 gram per centimeter cube among almost all the liquids. So it has to rise only till 76 centimeter of Hg, that is the atmospheric pressure. Whereas the density of water is only 1 gram per centimeter cube. Mercury is easily obtained in pure state and it's opaque so that it easily can be, and it's shiny as well, so that it easily can be measured. We can easily measure the level of rise and fall in mercury level. Whereas water is not available in pure state everywhere. Somewhere water is also available in polar regions or in cold regions as in the form of ice. So we cannot use water there, and as it is transparent, its visibility is not that much clear, the rise or fall in liquid level. Mercury does not stick to the walls of the container, so we can easily accurately measure the rise or fall in mercury level. It sticks to the wall, the water sticks to the wall, so we cannot measure the accurate measurement. Mercury does not vaporize, whereas water vaporizes in vacuum. That again will not give the clear rise or fall in the level to measure the atmospheric pressure. Another type of barometer is Aneroid barometer, that is also invented by Valencio Torricelli in 1843. Why? Because as we had just now discussed, there were many disadvantages of simple barometer. So to avoid such conditions or disadvantages, he invented Aneroid barometer. Aneroid means dry. There is no use of liquid here. It's very portable, easy to carry, small in size, lighter in weight and compact. So it's easy to carry from place to place. It's also used to measure the atmospheric pressure. Here in your book there is a outside diagram is given. Here I have taken the thing that is inside the Aneroid barometer. What's there? There is a membrane, stretchable membrane, with that one rod is attached. Along with that there is a wheel and a pointer. There is a circular scale that you can see from outside as well. So what will happen when the pointer, when the atmospheric pressure increases on it, the pointer rotates clockwise. The membrane goes down and stretchable membrane goes down, and the pointer will move clockwise direction. And when the pressure decreases, the membrane will go up, relax, and the pointer will move in anti-clockwise direction. Thus, we can measure using the circular scale the atmospheric pressure.